You are here to see Eric Fiterman, the founder of SpotKick, to present, is that a government in your network or are you just happy to see me? So with that said, I'm going to introduce Eric.
All right, thank you. Can everybody hear me okay? All right, even in the back, thumbs up in the back, you can hear me? All right, awesome. So for those of you who haven't spoken at Black Hat before or an event of this size, you actually submit the proposal for the talk months and months prior to the actual event, right? So I'm coming up with my proposal and my talk, and I'm thinking, well, I know I want a title that's kind of provocative, right? Because you can come up with something edgy at Black Hat, and it's relevant to what I'm going to be talking about, so I think this is the best title to have, right? But this was like months before any of the stuff with Ed Snowden, before he was running off to Shanghai, or before people were heckling four-star generals at the Black Hat convention. So I just wanted to start off by saying I'm not going to be talking about Ed Snowden or NSA surveillance, but we are going to be talking about some interesting stuff. So I know I've done my job if at the end of the presentation you come away remembering three key things. One, that the internet is being militarized. And what I mean by that, it's not just focused on what the U.S. government is doing and what we're hearing about in the news, but in keeping in mind that in a lot of parts of the world, the state, the government, and in many cases the military, runs, owns, or controls the telecommunications and networking infrastructure, right? So we've got a lot of government control over parts of the internet, and we're seeing the militarization of the internet. Second is that zero trust architectures, so zero trust computing, those types of models are going to be really important to deal with number one. And lastly, that open innovation, and open innovation to me is like the things we're doing here. We're exchanging ideas and information about the things that we're researching or the things that we're developing, and that's going to make us better as a community, better for our jobs and the things that we're tasked with doing. So just by a quick show of hands, how many people are familiar with zero trust computing or the zero trust model, just so I can kind of gauge? Okay, so a quick explanation of what zero trust computing or zero trust architectures mean to me. So Tuesday, I land in Las Vegas. I'm going to get my luggage from the luggage carousel, and I see a big banner from one of the log management companies, and it says, odds are your network is probably already compromised. I'm like, well, that's cool. You know, you got a big banner here, only in Las Vegas during the Black Hat convention. When might you see something like that? That is part of the zero trust philosophy, right? That because of the size of my network or the complexity of the things that I'm managing, I'm just not going to be able to control all of it all the time. It's going to be a place where other adversaries or other entities are going to operate, and I'm not going to be able to control that, so I'm just going to accept that, right? So zero trust is how we bake in features and controls and other characteristics to minimize the impact that an adversary would have once they're embedded in my network. And it also raises a lot of interesting issues, right? Because, okay, if I accept what the log management company is telling me that my network's already compromised, why wouldn't I assume that they're modifying the logs, right? Because if they're really good, they're probably going to turn off the logs, or maybe they're going to corrupt them. So if they're not already doing that, they probably will. So it kind of forces us to think in unusual ways, and it's a real challenge, and it's what keeps this job interesting, right? So I wanted to start off the discussion by kind of framing what's happening in the world of military spending. So this is a little chart I put together. This does not represent cyber spending. This is military and defense spending. And cyber investment, cyber intelligence is going to be a component of this spending. And I'll explain why I think it's a larger portion of these numbers in the next few slides. But just by way of comparison, so the United States, in terms of military spending, spends about 1.7 times on defense today than it did back almost a decade ago. Russia is spending approximately 3 times the amount today that they did a decade ago. And China is spending about 4.5 times in defense spending than it did 10 years ago, right? So now a defense or intelligence service actually has a lot of decisions it can make about how it chooses to collect and acquire information, right? There are decisions that are going to be made about what kind of platform gives us the visibility for the information we want. There's going to be some financial analysis, cost benefit, that kind of thing. And there's a decision-making process, for example, that goes into, okay, how do we want to collect information and how do we want to decide what to deploy? So here's a good example. So in the olden days, and maybe to some degree now this is still the case, but state-of-the-art intelligence is launching a payload into orbit, right? Very sophisticated, very expensive. Building, researching, and developing payloads that are going to get launched into orbit is probably one of the most technical and expensive processes that can be done. Very expensive. And I like to point out, actually, and this is not secret, this is not classified or anything, but even the United States launches a lot of its payloads using Russian rockets, because the Russians are still the best in the planet in terms of making liquid propulsion engines for rockets. And I like pointing that out because it kind of speaks to the complexity of the world today, right? It's not black and white, it's shades of gray. You know, here we have the United States military using Russian rockets to launch our intelligence payloads. And I think that's kind of interesting. So do we want to do that? Or do we want to use an internet connection at the Wank Internet Cafe that has a basic internet connection, they have great cappuccino, they've got plenty of parking for your Vespa out front, and they even have some air conditioning, right? So it's a very low frills approach to intelligence collection, but probably you could do most of what you needed to do for a cyber intelligence program from the Wank Internet Cafe. You can deploy payloads, you can monitor your infrastructure that's collecting information, you can pull information, extract information. It's cheap. It's a cheap way to do intelligence, but it's effective. And what this means is that unlike the era when collecting information, collecting intelligence meant you had to launch something into space, which was again very cost prohibitive, everybody's getting into this game now. And it's not just the ones that you're familiar with. Everybody's getting into this space because it doesn't take massive bucks to do it. It's also challenging a lot of our notions about who's in the intelligence business, right? Like WikiLeaks is not a country. I can't get a passport to WikiLeaks and go vacation there this summer. But they are in the intelligence business, right? They collect information, they traffic in information, and a lot of countries and a lot of organizations are very worried about that. I love that picture. I think it's real. So what all these things mean is that, in all probability, you have somebody in your network, something in your network, that can administer your resources as well, if not better, than you can. So what I'm going to be talking about today are some of the things that I've seen doing incident response and some of the tools and software that I've written to help people like you better manage and understand and get visibility into things that are going on in your network. And some of the things I've seen cover the typical folks that we're used to hearing about a lot of the news, and also some other parties that we haven't heard a lot about. And I'm also a developer that writes a lot of code. So my background is I have an education, I have degrees in computer science and engineering. I was a software engineer before 9/11. After September 11th, I became an FBI special agent responsible for investigating computer crime. And did that for a little while and then left, and have been working with clients to investigate data breaches and help them build newer architectures to keep things secure. Little software developer humor. Who doesn't love the Dos Equis guy? You could just make memes around the Dos Equis guy all day long. If you can't see in the back, I don't always test my code, but when I do it in production. Because it's exciting when you live dangerously like that, right? So here I'm going to present you with 3 techniques to help sniff out badness and bad stuff in your network. So one of the techniques, the first technique we're going to talk about is something I call trojanizing your own network, right? We're all familiar with what Trojans are. Typically, it's something that our opponent, our adversary, is doing against us, right? Well, I was working a long-term compromise with a large enterprise customer. We're talking multi-year compromise. And one of the things that we saw, and if you're in the incident response business, you probably see this too, but a lot of these folks are really efficient at using command line. And if you love command line, you know that command line can be really effective for automating a lot of things. It can allow you to do some very powerful things very quickly. It's also the desirable medium you want to use when you're administering covertly a network from around the world, right? You don't want to RDP and have to refresh your screen from halfway around the world. You want just a couple characters. You know, as you execute a command and you get some kind of response back, that doesn't take much time. So if you're on a low bandwidth, high latency connection, you're going to use command line. It's just what you're going to do. So our threat actors were using command line to mount shares and move malicious payloads around the network. So what I said to the folks who own this network is I said, let's Trojanize the shell. Let's put something in the shell that they might not notice, just so that we can maybe get a little more visibility if they get past all of our other things. You know, and this is an organization that has a lot of controls that we're familiar with, right? They have the standard stuff. They have antivirus. They have perimeter firewalls. They have some intrusion detection running. They've got a pretty robust security program. So I said, let's Trojanize the shell just to give us another data point if they get in and are able to pop one of our boxes. And here's how it works, right? So if you remember when most computer users were using floppies, we weren't networked yet, okay? So before everybody was networked, most viruses changed very infrequently, but one of the techniques that the virus authors were using were replacing legitimate executables, so the name of a legitimate executable, with the same name but with like a COM extension. Because when you were running different commands in the DOS shell, if you gave the name of the file without the extension on it, and one of these Trojans was in the path that the shell could see, it would by default, because the rules of precedence in the shell run COMs before EXEs, so it would run the COM file. The user probably wouldn't notice, and then you executed the Trojan and bad stuff happened, right? So I said, let's just do the same thing. They're using the net command. They don't run it net.exe, they're just running net. So let's just put something in. I'll make a net.com file. And here's what it's going to do. It's going to log, invoke a call to a Google App Engine application that actually is just a shell. It doesn't do anything. And just by the act of hitting that web service, you create a log in Google App Engine with any arguments passed to your request. So even if there's nothing there, if I initiate a call to my service with the name of the user who was running the command, what they were trying to mount, any of the arguments, all that stuff, I could log all that stuff automatically. And then what I'll do is I'll just seamlessly run the net.exe transparent to the attacker, and it'll mount what they wanted to do. So we're not trying to stop it. Let's just log it so we can get a little more visibility into what's happening. So again, this wasn't designed as our only hope. This was just one technique we wanted to use so that if they were able to get through our other controls, we still had another data point. And maybe this again, in terms of log management or enterprise analytics, maybe this is another data point that just helps me prioritize whether I'm going to bump this up in priority or down in priority. So another interesting thing we learned from doing this was that despite the fact that we were placing what looks to be a malicious file in the Windows System 32 folder on thousands of machines that beacons out to an external web service and has a COM extension, even though we were doing all these things that should have just raised all kinds of alarms with our antivirus solution, it just didn't even care. So on thousands of machines, we drop this binary and nothing happens, right? And this is this organization used a very well-known antivirus solution that probably all of you know very well. And again, it's what a lot of us already know, that antivirus it's 10 years too late. It just doesn't work anymore. So again, getting back to zero trust architectures, that's why that approach is going to be so important. So I've spilled the beans. If The attackers are in this room. You now know that you need to run net.exe and circumvent our little trap. But that's okay, because the reason I wanted to raise this was to explain that I think this is where we need to sort of align our thinking. We need to change how we think about defensive operations, and that trojanizing our network should be something we're more adept at doing than our adversaries. We need to be able to own our own architecture better than the adversary and use some of the tricks that they've used before, and to get results from doing it. So where do we go from here? What are some things that we could do to expand on this concept, right? So I think one of the things that we could do is work on building like a sandbox command shell environment. If we know sophisticated attackers aren't dragging and dropping things in Windows Explorer, if they're almost always going to the command prompt, which they are, let's work on building a sandbox version of command.com, which is the DOS shell environment, so that we can give an adversary the illusion of access to resources, but they're actually not able to do anything harmful. Right? So we're familiar with virtualizing. I'll virtualize desktops, I'll virtualize servers. Maybe we can virtualize and sandbox the shell to limit the damage that attackers do when they inevitably get in. So our adversaries were moving malicious files around using the net command, and they were able to do so because of another vulnerability in Microsoft Active Directory and Kerberos. And I know there were some other talks about pass the hash, and we're talking about pass the hash here and impersonation attacks. But this technique was so effective because of an issue in the way that large Microsoft domain networks manage identities and handle authentication. And so let's talk about that for a second. Kerberos. So Active Directory is based on Kerberos. So what is Kerberos? Well, literally it's a mythical three-headed dog. So you may see the three-headed dog whenever you're looking at Kerberos. But what Kerberos is it's a ticketing-based authentication system. So the way it works is that if I'm at my workstation, I'm already logged in for the day, and I want to access my Microsoft SharePoint site, it's a way to integrate authentication in with services around my network that invokes and involves tickets. It doesn't involve passwords. So that if I've got all this stuff wired up on my enterprise network, I can, once I'm signed in, request access to a particular server, and all behind the scenes without me having to do anything. I'm issued tickets that indicate I'm allowed to access this resource for this amount of time, right? One of the really interesting things about that is that the Kerberos capabilities are being used to implement single sign-on for things outside the enterprise. So Kerberos initially was more, okay, I have an internal network. I want to be able to give my users the ability to touch different things around the network. But what's happening now with things like Google Apps and Salesforce.com and all these other services, they're all being tied in Active Directory. So what that means is, if I can effectively perform impersonation attacks against Kerberos, I can access anything that my users can touch in the network and outside. And it's so effective because even though it's a ticketing-based system, the tickets are signed with something. And what they're signed with is a derivative of a user's password, okay? And the derivative of the user's password is their hash. So when a user's logged into their workstation and their credentials are basically sitting in memory, when I access these various resources, the tickets are actually signed with that hash, okay? That gives attackers a seamless view to basically access resources on the network just like a legitimate user. It's virtually or it's very difficult to detect. So pass the hash. Does anyone, another show of hands, let's do another poll. How many people know pass the hash very well? All right, so we're hearing more about pass the hash. And I was actually walking around the building earlier, and two guys behind me, I don't know if you're here, but there were two guys behind me talking about, oh, I just did a pen test, and I did pass the hash, and it was really easy, and they didn't know, how easy it was to execute. And pass the hash is like really amazing. You can do a lot of amazing things with pass the hash. So But I want to give you my quick recipe for how to do pass the hash. And it is low calorie if you're watching your calories. I didn't even get a chuckle from that. All right, that's better. All right, so what do we need for our recipe? We need a Microsoft Active Directory network. We need some hashes, preferably unsalted. We need a hash injection tool, plenty of them out there, and a little lemon zest for seasoning and flavoring. So the first thing we need residue. We need residue that's going to leave the hashes on a workstation where we're going to start our initial attack. And there are lots of different ways you can extract or get that residue. Sometimes they're cache logins, sometimes they're in memory, hashes in memory. So you just need to be able to make sure that there are hashes there that you can extract. You're going to need privileges or an exploit that gives you the ability to run a system to extract the hashes. And it's pretty easy once you find the tool that you want to use to dump the hashes out. All right. Then there's you need to figure out what tool you want to use to replace the hashes in memory. So again, if you kind of imagine what's happening is the user's sitting at the workstation in memory. They've got their credentials sitting in memory. That's a hash of their password. And what most of those tools do is just replace the in-memory hash so that anything I do from that point on, like with Kerberos, is going to actually issue me tickets in the name of the user that I'm impersonating. It's really good. Easy to do. So again, so once you do that, once you replace the hashes, you're able to access tickets, authenticate, access services, go outside the organization if they have single sign-on solutions, which a lot of large enterprises do, and you can kind of wreak havoc that way. And always wash your hands when you're done. And if you like that one, come talk to me about my spam loaf recipe. All right, so even though this problem has been around basically since Active Directory and Kerberos existed, and it's difficult if not impossible to detect the actual attack taking place, you can detect the characteristics, so the kinds of things that an adversary is going to do once they are able to leverage past the hash to get tickets in the name of a user they want to impersonate. So, technique number 2, let's turn pass the hash into trash the hash. So we've got 2 models of things that I'd call weird. That's the technical term. These are weird authentication events, right? So on the left side, we've got what I would call like a hub and spoke type event. Maybe I, as Eric, normally log into a particular workstation, and now you see Eric's identity being used to authenticate and do things on 4, 5, or 20 other machines, right? Well, that'd be weird because Eric normally logs into his workstation and now he's like on 20 machines. That's kind of weird. Another model, another kind of thing that you might see are what I would call sort of a daisy chain type of attack where Eric's account is used to jump from Eric's machine to Mary's machine. And then maybe Eric's account goes from Mary's machine to Kevin's machine. Or maybe Eric goes to Mary's machine and then you see another identity pop up, one that didn't log in using the normal ways that, if you have PIV or CAT cards, for example. And so you basically see identities changing and moving along a chain. So these are the kinds of things that you can detect because even though you may not be able to detect the mechanics of the attack, you're going to be able to see, in all probability, the things that they do with the tool. I'd also point out, we're all familiar with like the PIV and CAT card implementations. Totally vulnerable too. The PIV cards and CAT cards actually have some kind of character string that basically, even though you don't know it, once you authenticate on your workstation with your PIV or CAT card, again, an NTLM hash is generated that's static in most cases. It creates a static NTLM hash. So even if I pop a box that someone used only PIV cards because the boss said, hey, we got to make sure we get rid of passwords, and they're using the CAT card, doesn't matter. It still has a hash, so I can still impersonate users with the hash from their PIV and CAT card. So what I've developed is something I call BreachBox Core. It's a suite of Linux daemons for interfacing with authentication and identity information. So for those of you who might not be developers, a daemon is just like an automated process. It's just something that doesn't interact with users. It's just running in a Linux environment doing some task, okay? And I wanted to point out that it's logless. Again, because in a zero trust environment, I know that a lot of people are analyzing logs and log data, and that's good. That's a good thing. But again, in a zero trust model, if they're not already manipulating logs, they will. So, so this is logless. It rebuilds information straight from the wire. All right, so some features. You can deploy it as a span port, so you can mirror traffic going to a server or a domain controller, or you can actually deploy it in line. So as a transparent bridge, for example, so that you can monitor traffic that's flying through the box. Again, zero trust rebuilds it from the actual packets, not from log data. And if you still want to interface with your syslog environment or your SIEM solution, you can do that. And I've licensed it GPL version 2. So a couple components I wanted to explain quickly that make up the 5 daemons that make up BreachBox core. So you've got IPTD. So IP tables is the Linux firewall. All right, so what we've got is a daemon that allows us to dynamically send and update rules if we want to block particular workstations or IPs on the fly based on some event we've seen. We can notify and update rule sets for our firewall with IPTD. There's a Who's There daemon that facilitates querying the local authentication and identity stores so that we can find out who's supposed to be or who is on a particular workstation, for example. We have a daemon for monitoring CIFS. CIFS is the Common Internet File System. It's a critical part of Microsoft Active Directory. You can't turn it off. So it's file sharing, but file sharing that's used for authentication and other things. So you can actually see files when they're moving around, as well as monitoring events related to authentication. And then 2 daemons for monitoring Kerberos, one in TCP and one in UDP. So the code's on GitHub. It's under Rogue Networks. If you don't remember this or you don't write it down, you can also get to it by going to breachbox.com. So if you go to breachbox.com and scroll down, you'll see 2 links that link to the repositories if you forget. So real quick, the BreachBox core is set up to build an RPM, so Red Hat Package Manager. So you have a specs file with your spec indicating what it's going to build and how it's going to install things, and then your sources directory where all the sources live. You have directories for IPTD, Who's There daemon, IP tables daemon, and then your Kerberos directory, ksecd. And in that folder, you'll see the make files for csec and the Kerberos daemons. All right, so it's not a perfect world. There are a couple issues with BreachBox core. One, it doesn't support the latest version of CIFS. So there's a newer version of CIFS, version 2. It doesn't support it fully. The Kerberos protocol analyzer code I wrote is scary. I have a built-in TCP reassembly engine that I used. Initially, I was looking at using the reassembly capabilities for like NetFilter, but ended up writing something custom because it was faster. So in the core of the network, if you're going to be deployed inline as a bridge with like a domain controller, things happen really fast. And if you're not able to keep up with the speed, you'll start dropping packets and then you lose visibility into what's happening. So, and by the way, all this stuff's written in C for the same reason. And finally, I was deploying primarily with JUICE. So if you don't know what that is, it stands for Just Enough Operating System. It's a way to build very slimmed down images of servers, virtual servers, that have only the minimum services you need to, it helps preserve resources. And again, the whole idea is let's keep this thing lean and fast. So we deployed BreachBox core in an enterprise network, and a couple weeks into it, we've worked out a lot of the kinks, and all of a sudden, we start getting alarm bells. Oh my God, we've got an admin account, and it just touched like 20 or 50 machines. It's accessing shares on all these machines. Oh my God, we got them, right? It worked, we found them. So the IT security department calls up the guy, hey, we think your account's compromised. We just saw it. You were touching like 20 machines. Don't worry, we'll do a reset. We'll get your new. And the guy's like, no, I did that. So like, oh, okay. And he's like, yeah, I'm pushing out updates, and this is how I manipulate, this is how I deploy packages. You know, I like using the net command, and I automate this stuff, and that's how I do it. So it was an interesting lesson because, again, we're talking about how we have people in our networks that can administer things and manage them as well as we can. Our attackers, our adversaries, really are just administrators. They just happen to not have provisioned privileges to do it. They create their own privileges. So, and your administrators look like attackers. So be aware that that's one flavor of false positive that you might get. So again, breachbox.com if you forget where it is. All right, lastly, you probably have been hearing about something called profiling. We're looking at behavioral characteristics about things, either our users or our services or our systems. So this is another technique that I think is really effective that we can use to manage what's going on inside the network. So again, back when things weren't internet, the internet wasn't connecting all of our workstations together, blacklists for things like antiviruses worked great, right? Because malware authors weren't developing things that fast. And how long would it take for me to put my floppy in my my computer? It might be months, maybe longer. So blacklists were fine when things moved slow. Then we all got networked, and then blacklists failed. And so then it's like, okay, we need to think about whitelisting things because we just can't keep up with the way things are accelerating right now. And that's good too. But really the best way to approach how to profile services and do some behavioral analytics is to use math and lists. So these next two slides were really just excuses for me to put in funny pictures. So this is a picture of Las Vegas. Can you guys see the cloud in the back? You see the little cloud? Well, it's actually not a cloud. It's a frickin' nuclear bomb. So in Las Vegas, in the olden days, you could actually see the nuclear testing from Las Vegas. That's actually a postcard. So so I thought that was pretty interesting. So hopefully we won't see that in the next couple days. Math sets you to new heights. Anybody like that picture? It's crickets out there. Come on, guys. All right, that's better. So many spam detection systems work this way. Your Gmail, your other spam detection systems work this way. They use statistics and Bayesian methods to flag anomalies, to track things that they think are spam. So real quick, how does email look in a Bayesian world? So I get email from this lowlife named Skinner, and this is an example note, and he says, Eric, thanks for the note. Did you see the article about Walmart's employees, right? So a spam detection system would look at this and say, okay, I don't see any nefarious or blacklisted keywords. The email's referring to the recipient by name. This looks good. I'm going to give this a thumbs up. By the way, Skinner's not really a lowlife. He works with me. I just said that because he's sitting out there somewhere. And maybe he laughed at that. He's bald with an enormous scary beard, which could be like half the people here. So there we go. All right. I should open with that at the beginning. So now here's an actual email, a spam email I got. I don't know how they know that I'm on all three, Cialis, Viagra, and Prozac. You add cocaine, and probably that's in the bloodstream of most people here at Black Hat. But this looks like spam, right? Because we've got known bad keywords. They're not mentioning me by name. It's pretty generic. The spam systems probably saw it a million times, so that's spammy. So we can do the same thing for web traffic. So I caught the tail end of the prior presentation in here, and I think the gentleman was introducing new ways to inject, to do SQL injection or web injection to bypass web application firewalls, right? So this method is designed to combat these kinds of new attacks that just come up with new ways to encode or obfuscate arguments and exploits. So here's an example of a web API that I might have. So I have the push API, and it takes 3 arguments. So if I were building a profile, if I look at activity, again, this isn't manually done, but let's talk about doing this in an automated way. So if I have a profiling system that can look at the arguments and the way people interact with this API, the profiler would come back and say, okay, I'm figuring the C argument is an alphanumeric. It's between 9 plus or minus 2 characters. The TID argument is numeric 7 plus or minus 1 character. C-type numeric 1 plus or minus 1 characters, right? We're profiling how we expect our services to be used. So this way, when we see something like this, where we have a C argument that's alphanumeric, so the profiler can look and say, okay, that looks good. We have the C type that's a numeric. We expect a numeric 1 plus or minus 1 characters. That looks good. But for the TID argument, we're expecting numeric, and we received an alphanumeric plus control characters, and it's like double the size of what we should see. So what we could do then is pass that off to some other kind of an analytics engine and say, well, okay, I see why it was tagged, because it's a type of SQL injection, right? So a bit like the Bayesian things that we see with spam, we're doing a combination of keywords and listing and some analysis and analytics on the actual usage of the service. So the second bit of code that you can find on BreachBox, the website, or on GitHub, is BreachBox HTTP. It's a suite of a Linux daemon and a basic interface for doing this. So you can profile web services applications, build profiles, and then have a system to monitor usage and identify when something's happening that's out of band. So again, 2 components. You've got the daemon for building and enforcing service and argument profiles, and then a basic Django web app that you can use to kind of get started. We have a usage thing. How are we doing on time? We're about 40 minutes? Okay. Really quick, usage is, if you install Linux software, you're familiar with it. There's a tarball that, if you download from GitHub, you won't have a tarball necessarily. But you unpack the tarball, run configure, make install, and then there is a basic usage for building profiles for the service and then enforcing them. Like BreachBox Core, you have some flexibility how you want to deploy it. You can deploy by a span port or inline layer 2 for extra stealth. And again, the idea is let's use a hybrid scheme to reduce false positives. That's pretty much it. I know it's Thursday. It's late. Anybody watch Ancient Aliens? Don't be shy. Well, if you don't watch it, you should. If for no other reason, but this guy has the best hair in the world. And everything's about aliens. So I'll take your questions if you want to come talk to me. And if I don't know the answer is aliens. And I was told to remind you to scan your badge on the device that's not working in the back. Thanks, guys.